Hello, I'm Dr. Papia Bhattacharjee. In this problem, we have to write an exponential equation for y using this information that's given to us. And the information is that the first one is that the derivative of y will be equal to 2 times y. And the second part of it says that y is 10 when t is 0. That means that point 0, 10 is a point on the graph of this function. Notice that it is telling us what the independent variable is. It is t, okay? And dependent is y. And we are going to write down y equals a function in t. What kind of function? Well, exponential function. Further note that, look at the derivative. It says that the derivative of y will be proportional to y. And we know what kind of function has that property. Exponential function does, right? E to the x, its derivative is itself. E to the power any constant x will be that function times the constant. So only those functions have this property, that is derivative is proportional to itself. Using that fact, we can model this equation to be that we need our equation to be something like a constant times the exponential function. The most general, e to the power, not just t, but some other constant times t, because there could be a constant in the exponent as well. And now, using these two facts, we have to figure out what is our c, what is our k. That will give us a complete equation that we want. All right. So now we know what we have to find, and we know we have our information right here. So let's use them and solve this problem. Okay, I want to start with the second fact here. So let's start with the fact that 0, 10 is a point on the curve. Okay, what does that mean? That means it's already given when t is 0, y is 10. So you plug that in the equation and see if we can figure out one of the constants. All right, so y is 10. That's equal to c times e to the power k, and t is 0. Okay, notice that the exponent will become 0 because 0 times k is 0, and e to the 0 is 1 using the property of exponent. And so we have the value for c. c is 10. All right, so c is 10. Next, let's use the first fact, that the derivative is equal to 2 times y. How do we use that? Let's start with our equation and let's take the derivative. Then the left hand side will be dy dt, and we can plug in whatever dy dt is. So let's start there. Y is equal to c e to the kt. Now let's simplify and rewrite this equation one more time since we already know what our c is. So this is y equals 10 e to the kt. And the next step, let's take the derivative. So left hand side we have dy dt. Right hand side we'll have d dt of this entire expression. Okay, now dy dt is 2y. And here 10 is a constant, pull it out. And the derivative of e to the power kt, you can use the chain rule. First is the function itself, and then take the derivative of the exponent. So you multiply this by k. Okay. Now, notice right away, this is not an equation just in k. So k is not the only variable. We also have y, we also have t. But we know from fact 2 that y is 10 when t is 0. So that point is going to be on the graph. So again, we can use that fact in this equation, and then we can get rid of y and t. Okay, so let's rewrite this one more time. And we know y is 10 when t is 0. Plug that in the equation. So 2 times 10 is equal to 10k e to the k times 0. So 20 on the left, right hand side 10k, and this is e to the power 0, which is just 1. So 20 divided by 10 is equal to k, and so k is 2. So k is 2. And as soon as we have both these constants, we can write down our equation, and that is y is equal to c is 10 e to the power 2t. So that is an exponential equation for y that will be using these two properties. Finally, notice that since k, the constant in the exponent, its value is 2, and therefore this is positive, therefore we know that this equation will represent exponential growth. Because positive exponent means the function will increase, and so it will have a growth. So that completes this problem. Thank you.